you're asked to find the volume below the plane z equals 2x plus y, and above the region in the xy plane bounded by y equals x and y equals x squared. So this is one of those ones where you can get away without having to draw a z, because I'm told exactly what equations create the boundaries for R, and I can get my limits of integration that way. And I know that when I'm finding the volume between a region in the xy plane and a surface in space, the ceiling is just the surface and the floor is 0, so we don't have to take that into account, right? So the integrand is just z, in other words. So I will draw the region in the xy plane, but that's all I have to do as far as drawing pictures. And you've seen me draw this at least a couple of times already. So y equals x squared, just a quick sketch. It's the important part of the parabola is right there. Y equals x, 45-degree line is going to intersect the parabola at 1, 1. And so R is in that region right there. So x, y, I know how do I know it's positive, by the way? It's important. If we're going to call this a volume, it's important that z is positive. How do I know it's positive? X and y are in which quadrant? First quadrant. So if you take two numbers and multiply one of them by 2 and add the other one that are both positive in the first quadrant, or at least non-negative, your function's going to be non-negative, right? And in fact, positive here, unless you plug in 0, 0, I suppose. Anyway, it's going to represent the integral we're about to set up will represent volume. So here we go. The integrand is just 2x plus y. Now, to relate that to what we were talking about with triple integrals, the plane z equals 2x plus y is floating out in front of the screen somewhere, right? And that's the ceiling. And the floor is just in the xy plane at a height of 0 inside this region, right? So what we're talking about then with what we just set up, floor, ceiling minus floor, it is consistent, right? Because if you take the ceiling minus the floor, z equals 0, you do get the same thing. So I just wanted to mention that. We'll go with dy dx, right? But if you know the floor is something else, as we've already seen today, you subtract off the bottom function, which represents the floor. And then if you wanted to make a triple integral out of this, you could. So the upper limit would be 2x plus y for the inner limit, and the lower limit would be 0, right? But again, that's not what you were meant to do here. So let's just stick with what you were meant to do. Okay, so the integrand is 2x plus y. And we'll go with the differential order dy dx. Okay, that means what kind of representative rectangle in R? Vertical. I drew it a little too long, but what's going to give you the bottom inner limit? The parabola, the curved one. And the upper limit? Upper inner limit would be given by the top of that guy, which is given by x. And what does x run from? 0 to 1. And that's the setup. And I think I'm going to let you guys take it from there.